Hello again. So in this video we're going to have a look at fixing this Bosch battery charger. So this is a little drill driver kit I bought I think a good 10 years ago. Both these devices do have a code of 2012 on them, which could be the year, I don't know, could be something else, but I think they're at least 10 years old. It's fairly sort of old technology now. 10.8 volts battery in here with, you can sort of see it's sort of triangular profile. It's probably got 3 cells in there to make the 10 volts, 10.8 volts. It sits on my workbench in the garage. Normally it's very dusty and dirty in there, and last time I tried to use this, it's got a handy battery state gauge on the side. It was down to one bar on the battery. So I thought I'll just pop it in the charger to top it up, and as soon as I did that, it charged for about I don't know, about a minute or so, quite happily, and then it started making a fizzing noise, and then it made a little pop and smoke came out, and that was the end of that. So you can get new replacements of these chargers online, both Bosch branded and sort of replacement ones for I think about 35-40 quid, something like that. But I thought let's open it up and see what went wrong and maybe see if I can fix it. So here's a closer look at the label on the back of the charger. We've just got the 5 screws here that we need to undo to get into the case, so I'll do that first. Alright, so let's see what's inside. I'm expecting there to be at least one component quite obviously burnt, because it made a very distinct pop and the magic smoke escaped. So yeah, having looked at this circuit board more closely, it looked a lot cleaner than I was expecting. I was expecting to be a massive skid mark somewhere and some damage, but having looked a bit more closely, I think the problem has got to be this capacitor, this yellow rectangular capacitor here. It's got this lump on it, which I originally thought was just some sort of mastic or something, silicon to stick all the components together. But if you look down the side of this, if I try and get this at the right angle, you can sort of see that the side of this yellow capacitor is bulged out as well, and then this black stuff has obviously oozed out from the inside, I think, and solidified. It's very solid now, but it looks like that's what's gone wrong. This capacitor on the input, like the mains power input, has failed and melted. So I'm going to see if I've got a spare one of these anywhere in various boxes that I've got lying around. Otherwise I'll maybe order one and replace it. So got the item off the circuit board there, so you can see, I think you can see how distorted that is. Something's gone inside there, the case has split on this corner, and this shmoo has oozed out from inside and then solidified again, so definitely not right. So I just need to look up, I haven't got any of these around, so I'm going to look up where I can get one of these, get one ordered, and then we can try and repair the circuit board. So it's a few days later now, and I've got some replacement capacitors through the post, so I'm going to fit one of those in a second. They're 0.47 microfarads, Class X capacitors, pretty standard stuff. Cost me about £3 each with postage, but you can get them a lot cheaper if you buy them in bulk. So I'll fit that back in place of the one I took out. Hopefully that was the only fault, but it's always possible something else has gone wrong on this circuit board, and that was what caused the capacitor to fail. It was a bit odd that that capacitor failed open circuit, as far as I can tell. So the whole point of a Class X capacitor, according to my quick research I've been doing, is that it's a special type of capacitor that is meant to fail short circuit, which is why it goes across the line and neutral on this type of power supply. So if it does fail, it will cause a short circuit and blow a fuse or something and cause the device to just be completely isolated. So that's not quite what happened, but maybe I caught it and unplugged the thing before it actually failed completely. So the rest of the stuff on here, I haven't reverse engineered it all big Clive style because I don't understand it all well enough to do that really, but I can see you've got 4 diodes there as a rectifier. Obviously you've got the inductor, transformer and so on to sort of regulate power. 2 big MOSFETs here with the big heat sinks. These are obviously controlling fairly high currents to the battery, so they get hot and they need the big heat sinks. I think these ICs are probably just sort of opto-isolators, something like that, to provide feedback to those circuits. You can see on the back here there's quite a good sort of distinct line between the high voltage side and the lower voltage side. And on this side, I had a quick look at the part numbers on these ICs here. So one of them is just a standard sort of op amp. I think it's 4 op amps in a package. It's pretty standard kit. The other one here is a bit harder to find. I think it's some sort of microcontroller, this one on the left here. So that's doing a bit more maybe custom intelligence for the charging circuitry. And then the big black box over here, this is a relay. I was just a bit surprised to find a relay in when I opened this charger up, because I've never noticed hearing a relay clicking when using this charger in the past, but yeah, there is a relay there, so that's I guess connecting the main charging current to the battery once the rest of the circuitry is happy that a good battery has been installed. Alright, so let's get this new capacitor put back in and then we can try and power this thing back up again. Okay, so that's not the best soldering job, but it's in there now, and this leg on the right here is definitely, I mean, the way that trace had come a little bit away from the circuit board, I mean, that's not great, is it? So I'll see if this works now, get it put back together and see what happens. But there definitely was a bit of damage to that trace, so it is perhaps would be more wise just to throw this in the bin and buy a new one. But let's see if that new capacitor will actually let it work, at least, just out of interest, and see if it can charge the battery back up. Back in a moment. Okay, so let's plug it in, see if anything goes pop. Alright, so I'm switching the power on now. I've got a green LED, so that's good. No smoke. That looks promising, so I shall put the top cover back on and see if it works. Okay. Okay. So I'm going to switch the power back on. Try to get this where it is visible. I've got the green LED back on again, which just indicates that it's powered up. And if I get the battery that goes in here. So that's the standard Bosch battery. Plug that in. Okay, I've got green flashing, that indicates it's charging. Okay, well, I'll leave that going for a little while. Hopefully nothing bad happens, and I'll be back once it's charged and we'll make sure it's all worked correctly. So I'll actually do a quick test on the power consumption of this thing, just out of interest. So it's currently unplugged. I've got my power monitor here, so you can see we've got 246 volts in my part of the UK today. And if I switch this to the power reading, there we go, so currently 0 watts. So if I'm going to plug in the charger without anything attached to it, and no battery installed, about 2 watts. I guess that's probably as expected. Got the little green light and just the power circuitry running in there. Now if I plug in the battery to charge it, should see that increase quite a bit. It's gone up to 46 watts, so that looks reasonable. So what's that? If it's using say 40 watts to charge 10 volt battery, that's going to be about 4 amps. Sounds about right. I don't know what the capacity of this battery is, to be honest. They didn't seem to be so bothered about giving you the amp hour rating of all these batteries in the old days of cordless tools. But yeah, let's see how that progresses, and we'll see how much power it uses over time. As the battery fills up, it should reduce the charging power as it goes. So we'll be back later. And I'm back already because I've just been watching this, and it's only a few minutes. I have to check the clock on the previous bit of recording there, but it's only about 5 minutes later at the most, and you can see the charging current is, or charging power is already steadily decreasing, which I assume means either the charger is about to explode, or assuming things are working correctly, it's just that the battery has taken quite a good initial charge, so the voltage on the battery is ramped up pretty quickly, I guess, and now the amount of power that the charger is putting into the battery is steadily decreasing as it gets more and more charged. It's quite interesting to see how fast that's changing. But anyway, we'll keep going, and I'll be back later when we see if it's actually worked correctly all the way to a full charge. So more time has passed, and as you can see, the charging power is now right down to 7 watts, and the steady green light has come on. So ordinarily this, I would just assume that meant the battery was fully charged, although it does seem that the charger is still putting some more energy into the battery, and the charging power is slowly coming down, although slower than it was before. So I'll leave it for a bit longer, and we'll see if that continues to be the case. Let's see if I take this out of here now. So the charger goes back to its kind of standby power, 1.9 watts like it was before. I'll put the battery back in. I heard the relay click that time. There is a relay in there, as we know. So it's gone up to 7.5, but rapidly coming down again. And it's indicating steady green to indicate it thinks the battery is charged. So it's like maybe it's kind of, maybe the steady green comes on when it's at like 99% or something, and it just carries on charging for a bit longer, as long as it's on the charger. I'll give it another sort of half an hour or so, and we'll see what happens after that. Hi again, so just back for a final look at this, and so after about another, what is that, 45-50 minutes since we last checked, we've still got the steady green, but the power has now gone right back down to kind of the standby power of about 2 watts. So yeah, it looks like it does continue charging a little bit more after you get the steady green, so maybe it's worth leaving your batteries on the charger for a bit longer. But I think that should all be fully working now. I'm going to try this back in my drill just to make sure we get what we think we want. Yeah, got 3 greens there on the power meter. So fully recharged battery, the charger is working. It did get quite warm, but it's cooled down again now. So I think that's a good fix. Maybe not the neatest fix, but it certainly saved me having to buy a new charger, so pretty happy with that. So thanks for watching, hope you found that interesting. Drop me some comments and a like and all that. Tell me what I did wrong, and I'll see you next time.